Good morning, good afternoon, and good evening, everybody, and welcome to another episode of Loosely Coupled by Bridging the Gap. My name is Karol Skrzmowski, and I'll be your host tonight. Hopefully, all of you have a lovely cup of something to drink for this session. Don't know if you noticed. If you're coming back to the stream, maybe you have, but we actually have a jingle today. That's made by my co-researcher at Bridging the Gap, Philip Costera. Thank you, Philip, for that. It's a work in progress, but it's already pretty nice. Philip doesn't want to say that this is a ready thing. He said he'll work on it in January, so maybe there will be a different version, maybe a longer one. But that's not the topic for today. This is actually the last stream this year. And here today we have a lovely topic of interoperability, so actually something we do at Bridging the Gap. And today, a different angle. We're going to be talking about interoperability in frontends and specifically micro-frontends. And who better to talk about interoperability in micro-frontends than the author of the book, Building Micro-Frontends, Luca Mezzalira. Luca, welcome to the show.
Hi, everyone. Thank you for the invite, Karol.
Happy to have you. Luca, you've been at it for the last, 21 years? Doing IT stuff, architecture, and whatnot?
Yes, more or less. I think 24 in January.
24. Whoa, okay. 24 in January. Wow. You wrote me in the bio since 2004, so I'm like 21 years.
And no, I did also something before that.
So that's in architecture.
So if we want to start on the very beginning, yes, the 2004 was the first line of code, if you want. But I did also some stuff before that.
Fair enough. Luca, micro-frontends, how old is this topic? Because you've been at it for a while already.
Yeah, I'm ranting about micro-frontends for almost 10 years. So next year, if I remember well, is in May, there will be the first decade of the term micro-frontends that was coined by ThoughtWorks, by... so it was one of the developers in ThoughtWorks came up with this idea, Mr. Jackson, if I remember correctly, and then it was advertised inside the Tech Radar that they usually do twice per year. It was the first half of the year, if I remember correctly. Therefore, I started before this term was coined in 2015, thinking about micro-frontends and how I can apply the principle behind microservices in a way that makes sense for front-end. And then suddenly, in 2016, we started the development. It took me a good amount of time having the buy-in inside the company, because as you can imagine, if you go to a CTO and you say, okay, we are going to do this in this architecture, and at the question, how many companies are doing that? And the answer was probably one or two in the world. It wasn't, let's say, the most sustainable things that you can say to a CTO. So we need to prove that. So I had like a team of a few engineers that work with me in order to create a, let's say, POC that would show how we solved the challenges we were facing in our monolith. And that basically was the beginning of the story of micro-frontends.
I mean, 2015 in Poland at that time, I think people barely heard about virtualization. They started hearing. I remember going to a session with Microsoft somewhere in Warsaw. They were showing off their Hyper-V servers. Yep. That was the pinnacle of virtualization back then. In T-Mobile, we were still running some servers on bare metal. But these were just huge monolithic servers in that sense. So we had like separate servers to have high availability. So that's quite a long run already.
Yes.
10 years. Yeah, you started early, basically.
I started for a necessity. The problem that I had to solve back in the days was being part of a startup that turned out to be a unicorn based in London. And we moved from 50 people to 3,500 in something like a couple of years. Because challenge was we work with a lot of partners. The first iteration was working with partners. I was working for one of the partners, and I follow basically the integration with different tools that we were using, because we were the company responsible for the front end as well as the middleware that was aggregating all the data and then generating also other data. And then after that, after the first release, I've been asked if I would be interested to join this company that I was working for. And the answer for me was like, yes, without any doubt. Because the idea was scaling the way how we were doing the first release of the software, but most importantly, revolutionize the way how people were consuming live sport. And at the time, Netflix was starting to boom properly. And if you think about that, it was like a perfect storm where you have like sport that you don't have to explain to anyone what sport means, and you have like streaming, on-demand streaming that was starting to grow. And I found myself in a situation where I was the second tech person hired in that company, and they told me, okay, now we need to internalize all the things that we have done with partners. So we need to create all the hiring process, all the architecture, all the team structure, all the engineering practices, and so on. So, and I was basically the second person that had a lot of say on all these topics and looking holistically on the social technical system that we were building. And we started to introduce things way before certain things came out, like the idea of team topologies, for instance, was something the book came out in 2019. We were doing that in 2017 internally. We didn't have a name. We were just, let's say, leveraging domain-driven design for splitting up, let's say, our application, find the boundaries and subdomains, and then co-locating, because it was pre-pandemic, co-locating the people working on the same subdomain in the same hub. Because we have 4 different dev centers, one in Poland, in Katowice, one in Amsterdam, one in Leeds, and one in London. And basically aggregated these subdomains in a way that the worst case scenario, you solve the problem with the person that is like 10 feet from your desk and not on a 1 hour difference or in another city or even in another country. So therefore, that idea accelerate basically the storming and forming of the teams. And also we know upfront that in order to solve the problem of let's say communication across different hubs, it was just working properly with the API contract first and having, let's say, strong governance around, I need to change an API, perfect, write an RFC and start working to that. So we started to create a lot of practices that I recognize in nowadays that I'm in AWS, that many companies currently are still at the beginning of the journey that I did, let's say, almost 10 years ago. So it's very interesting because it seems that we were extremely futuristic to a certain extent. I'm pretty sure other companies have done what we have done at the time. But for many enterprises I'm dealing with right now, a lot of learnings that I have went through over the past decade are definitely helpful for them to, let's say, embrace this new world of modernized software, modernized architecture.
Now, okay, but that's a handful. I'm like sitting there. It's like the light bulbs switching on in my head. Okay, Conway's law, team topologies, cognitive load. Oh, so many of those topics. There's so much to unpack here.
Yes.
Basically, you were at the forefront of developing new approaches in tech, and then actually had practical experience when they already were named and went out with specific names. So you already had experience in dealing with that in practice.
Yeah,
that's a rare thing.
It was because it was the cool thing for me was I was let's say a person that loves to work in bleeding edge context, where things you don't know if they are going to work or not, because we need to bear in mind that in 2015 when we launched the first release of the Zone, there wasn't this idea of live sports streaming. Many people were telling us there is no way you can succeed. No one did that before. There is the cable providers. That is the normal way how to consume sport back in the days from Sky and many others, where the way how people were consuming. They were working perfectly fine. We believed that we can democratize even further sport and reduce the cost. And in fact, the first few years, the cost of our subscription was less than 10 euros per month. And you can consume everything that was available in your country. Obviously, we started with 4 countries. The first release so was Japan and DACH, that basically is Germany, Austria, and Switzerland. And in Japan, for instance, we acquired for 10 years exclusive rights for the J League, that is the football or soccer for our friends in America. That leagues we bought like the first one, second one, and the third one. And
Wow.
after that, in 18 months, we became almost the only sport broadcaster. The only thing we didn't have was sumo. But we had everything else. We brought, let's say, all the other sports from US, a lot of sports from Europe, the Champions League, and all the other things. So it became extremely popular in Japan. And I remember when I was working there, because obviously I was used, let's say, more or less in every single launch, staying in the war rooms and seeing how the things were panning out from our first Datadog and then New Relic dashboards. Quite fun. But I've seen, let's say, the power of these things. If you were, let's say, walking through Shibuya, that was one of the key area of Tokyo. In the Shibuya station, the station was completely packed with our advertising. You can see, let's say, our brand everywhere. When we launch in Italy,
Wow.
in Milan, we have near the San Siro Stadium, that is the AC Milan stadium. There was like the stadium was called the Zone Stop. So it was like we started to grow like crazy. And obviously the way how we were designing things and implementing things at the piece that we were doing everything was quite monumental. At the end of the day, after a couple of years, we reached like 550 techies across the tech department, spread in 4 dev centers.
That's a lot. That's a lot of stuff in a very short period of time. Then
Correct.
So not only were at the forefront of developing new approaches, you also had the organizational challenges of extremely fast growing company, which I can imagine that was, for some people, not all of them, but for some people, that must have been extremely stressful.
Yes.
To get through that. The growing pains of a company growing that fast. This can be really great, or can be really, really tragic for certain companies if they don't adapt and adopt in a very fast manner.
I think our strength was, let's say, trying different things, analyze what we were doing, and see where we were failing, and adapt as fast as possible. And I found myself having, let's say, every other week a brand new team of at the beginning contractors, then replace with internals to onboard these teams every other week, explain the architecture, explaining what we were trying to do, and all the other things. And that's why back in the days, because we had to support, the idea was supporting roughly 40 different targets on the front end, so set-top boxes and living room devices, or console, web, mobile. So if you start to put everything together across the world, you have like devices that were as powerful as a Nokia phone back in the days, that were set-top boxes, but the penetration of a set-top box or a smart TV is by far larger than the newest one. Because if you think about how often we change a TV or a set-top box, it's not happening very often.
No.
So there were devices that were quite obsolete, technologically speaking, but in order to make them cheap, they didn't have, let's say, amazing chipset or crazy codec or whatever. You need to adapt yourself in the way that in the things that you want to you need to develop. Therefore, also one of the idea behind Micro-frontends was it was also one of the key aspect is trying to reduce and optimize the memory management in JavaScript, not loading everything in one go like you could do with a single page application. And therefore lazy loading what is needed when was needed. And I think we did a pretty good job overall. on doing that, and that basically it not only enabled the performance but enable also to have teams that were working independently, because now with the good segregation of concern and division of about domains, we were capable to say, okay, so this team is responsible for this part and that team is responsible for that part. We had to iterate for more or less a year and a half to figure out the right split and understanding and fixing all the different problems, because obviously, as you can imagine, because it was so novel, this approach, there wasn't documentation, there weren't, let's say, any book that could tell you, oh, this is the way that you should do, or someone that you can say, oh, let's call a consultant that help us to do this. We were
They
on our
couldn't.
own completely. So all the meetings that they organized with, I don't know, 10, 15 developers, for trying to analyze the problem, trying to see the patterns we can apply, try to see what fit, what didn't. After, let's say, a couple of years, when we started to launch on the web first, I thought that we were sitting in something extremely interesting, because it was let's say, journey of 2 years gathering feedback from different, let's say, developers, from junior to senior and principal, etc. And then I remember the first talk very vividly that I did in Dublin, where I went on purpose, and let's say, conference was not too big, but was big enough with hundreds of people. They gave me like 35 minutes for delivering the talk, and I spent roughly 4 hours answering question after. It was like
Wow.
I couldn't have lunch. Because people literally assault me on asking, okay, how do you manage like the design system? How do you do this? How do you do that? And it
Right.
was extremely funny on one side, and extremely rewarding on the other side, because we work for something that probably no one, let's say, explore at that depth that like we did. And then suddenly there is an interest that is out, but all companies that were huge compared to what we were at back in the days. So for me, it was a great reward and great moment overall, despite there were other lows later on during the journey. But here we are. We have, let's say, Micro-frontends that basically use everywhere, from all the largest enterprises in the world probably are using some shape or form of Micro-frontends.
Well, now luckily we have people that actually specialize in micro-frontends. There are reference to go with. So one of the reference here on screen, that's Luca's book, Building Micro-frontends, second edition. That's very fresh, right? That was this year.
Yes, so it was released in early November 2025, 2025. And the cool thing is that basically it was a complete rewrite. I kept like half of the book and update every single chapter with the latest and greatest. But then I basically gather all the feedback from the first edition, where they were asking, can you share more code? Can you do more of this? Can you do more of that? And then gathering the thing that shifted basically the gear between the first and second edition is that I joined AWS right after I published almost the first edition. I was about to publish. I wait, let's say, a few months more for gathering more information. But since then, basically in the last 5 years in AWS, I work with hundreds of teams, internal teams from Amazon, AWS, etc., and customers from Silicon Valley to New Zealand in different industries, finance, entertainment, retailers, etc., healthcare. And we started to I started to collect all the patterns that I was seeing and mistakes that were happening in the trenches. That I think that was, let's say, a great effort for the community, because what I was thinking is, okay, let's validate what we wrote in the first edition and let's add other new approaches that were surfacing there and generating the vocabulary like I did in the first edition, because the vocabulary, as you know, naming convention and ideas that you need to convey require a certain type of language. So for me, now I'm working certain engagement with customers where they are talking the language that I created back in the days. That is insane on one side, but is extremely helpful because everyone is on the same page. And that doesn't matter if they are in UK, in US, or in New Zealand. We will talk exactly the same thing. So we are on the same page. We start to discuss what kind of challenges they have. It's a completely different way. And I have to say, one day I will document properly how to create a vocabulary for an architecture, because I
Ooh.
realized that there is a lot of thought process behind that, and why certain things were described and designed in a certain way. And after 10 years, I have a lot of data points that I can say, okay, I can identify what are anti-patterns and what are patterns that you should embrace, and how in the influence of other, let's say, architectures help me to reach, let's say, the maturity level that we have currently in Micro-frontends.
Yeah, you said a word that triggers me into asking, because I did plenty of research in terms of patterns and anti-patterns, and when I was designing a course on integration architecture some time ago, I struggled with finding a decent definition of an anti-pattern. What's your definition of an anti-pattern?
So it's the opposite of a pattern. Or better, what I would define is an approach that, when taken, it will generate more friction than benefit for a company. It doesn't mean that it will always generate that friction, but it's likely to generate friction. There is this concept that I truly believe on, where a pattern is a solution for a common problem. But not always you want to embrace best practices or patterns, or you want to embrace anti-patterns sometimes, right? Because the reality is, and that is, me becoming more mature and having more experience and more years under my belt, the fact that in the past, as a developer, you are dogmatic. You say, okay, this is MVC. You implement MVC by the book. You implemented the pattern by the book. And if someone is trying to convince you that this is the bad way to implement a specific part, you say, oh, no, but you don't understand. Because in reality, this is a pattern. It's documented here, the Gang of Four, so see it. And now instead, I'm more into the trade-off analysis, like Neil Ford and Mark Richard recommends, where, okay, so let's try first to analyze what we need to express inside the system or inside the feature. And then after that, when I have like the business capabilities crystal and clear in my head, I have the architecture characteristics. I hate the non-functional requirements, so don't ask me to say that. Architecture characteristics.
I subscribe to that.
Architecture characteristics that I need to express inside the system, because some of them I need to apply across the entire system. Some of them I need to apply maybe in a specific domain, generic or core or supporting. And therefore, if you start to work in this way, you start to have, let's say, clarity of what you can and what you cannot do, at least. And then you can challenge, obviously, this, let's say, specific implementation, because maybe it's a snowflake, or maybe you discover that it's not. But unless you start to have, let's say, a conversation that you first understand these two layers, basically as business and what architecture would like to see, for obvious reasons. Sometimes you're working in a regulated environment or industry. Sometimes is let's say something that is a decision made by the company or by the CTO for maintaining high availability. So these kind of things matters and affect your design. And therefore, for me, when I have those, I can start to drill down into, okay, now that we know this and we know the specs, we know what we need to aim, we shoot for, okay, how we design these things. And it's one thing that I believe now we are a bit losing, because we are rushing towards the implementation phase due to time commitments that are not, let's say, managed by us. But I believe that the architects that are still useful should enable teams to, let's say, reframe these things in a way that they will enable to quickly have this information, key business characteristics, key architecture characteristics in a digestible way, and they can, let's say, incorporate in their design when time comes.
So for those not having the frame of reference for all the terms that Luca just used, which are the terms we've been using on this live stream for quite a while already, because I do subscribe to all the terms described by Mark Richards and Neil Ford. I absolutely love their rhetoric around building architecture and doing trade-off analysis. But while you were describing this, I took the liberty of grabbing some links from O'Reilly. So if you need a reference to all those lovely terms that Luca just mentioned, Head First Software Architecture is a great book to start with. Very light read with exercises, with lots of fun for the brain. And if you need more of a concrete read, then Fundamentals of Software Architecture, the second edition, was also published this year, earlier in
Yes,
the year, as far as I remember. O'Reilly says March 2025. These are really great books to find all the definitions of the terms around architectural characteristics, doing trade-off analysis, looking at all the different factors that come into the design of your architecture so that it actually is fit for purpose rather than art.
exactly.
Right? So that's the biggest value. Being dogmatic, I was dogmatic as well. I used to have that approach a few years back. Learned the hard way that being dogmatic is not exactly the best approach, because at a certain point with one of my clients, I actually looked at it and it's like, oh, this will completely not fit the case, and I've been proposing that. It's like, no, that's just going to be a huge failure. Luckily realized on the design phase, not in implementation.
Yeah, exactly.
But basically, after that, I started looking more into trade-off analysis and actually analyzing the context and spending more time in the problem space, analyzing what the main problem is, and then diving into details of design and picking the right tools for the job. And while your short answer for the anti-pattern, I was instantly like, oh no. And then you elaborated on that, and I was like, oh yes, exactly that. I'm joking with Mark a bit. Mark actually introduced a third term to the mix. Pattern, anti-pattern, and a pitfall. So now we have pattern, which is a common solution for a common problem. Anti-pattern, which is something that usually leads to problems when misused, but is also a pattern. So it also solves some problems in a very specific context, niche context usually. And then pitfall, something that is definitely not wise to do.
Yeah.
So that's their classification of different aspects, and that goes on all levels of abstraction. There are patterns and anti-patterns everywhere. I have my own specific integration patterns and anti-patterns and pitfalls. Always a fun discussion, but not today.
Yeah.
So, having all that amazing background, because that's been quite an interesting story, maybe we should dive into those front ends, shall we? So starting with, what are micro-frontends?
Yeah, so
that's the interesting definition then, after
yeah,
10 years of working with them.
Let me, more than just sharing the cold definition, and let's say walking through my reasoning when back in the days I started to think about that.
Okay.
So the idea was very simple. On the back end, we knew exactly what to do. So we knew that we needed a distributed system. At that time, cell-based architecture was still, let's say, fuzzy, very far away, and we were just starting. It didn't make any sense using a cell-based architecture. But the microservice one definitely made sense, because we were moving from a monolith to this distributed system with a lot of engineers, etc. So when I started to think about what characteristics should I apply on the front end, the majority of the time and all the different implementation I've done in the past were in a monolithic space, where literally you start with all the good intentions. You start to scale the teams, because usually you start like one team, start to build a small POC, then start to grow, and slowly but steady you have like 5 teams, 6 teams, whatever. When we were working in this specific project, we were roughly 40, 50 people end-to-end in my previous company. And we were working with monolith in the front end and monolith on the back. At some point, the problem we were facing is and that's something that I've seen in other companies when I was working as tech lead. We started to slow down with the new features implementation, because now the code is larger and more complicated. People were stretched a lot. When you were on call, you need to take care about, sign in, as well as payment, as well as catalog, as well as any other part of the application. And you cannot squeeze everything inside your head. So the cognitive load that we were discussing at the beginning. The other challenge is that because there were some features were, let's say, easy to implement, we couldn't deploy them quickly, because we need to retest due to, let's say, issues that happen or bugs that were happening when we started to build stuff and deploy stuff. We are more careful on what we want to deploy, so there were more tests, either automation or with manual QAs. And so if you start to put everything together, you see that there is an inherited complexity when you reach a certain point, not on the code side, that I would say in every company I work for, there are some times that you have spaghetti code, but majority of the time you have, let's say, people that really care about their craft and they want to do the best, and that's why it takes longer, but also helps to optimize certain things. That could be refactoring on performance and other stuff. But the problem we had is now we have a completely different ballpark. We know upfront that we're going to scale. We know upfront that we need some teams that are going to take into account different domains. Therefore, it was stupid for me starting with saying, let's use the same approach, because otherwise we arrive to a bottleneck where the backend started to have microservices. The front end as a monolith, they start to have bazillion of feature flags spread across the code base, and we are not going to have time for fixing that. So we need to think about a different approach and looking into the characteristics of microservices. So you know that are define units that have strong boundaries, not only on the code level, but also on the infrastructure level. And that is one key aspect of micro-frontends. Therefore, we need to have an artifact. In the case of microservices, was a container back in the days, or a VM, that is strong enough that I deploy this chunk independently from the rest. That is not only code that I build at runtime, but I build at compile time, but is something that I do at runtime in the case of the front end. So I load a chunk of the system and I lazy load a chunk of JavaScript. And that was the first assumption. The second one is I want to have the team independence. Therefore, shareability, we need to be careful. We need to rewrite the game where in front end, when you have like 3 lines of code that repeats twice, immediately you create a library. And that is evil, because when you have, let's say, a lot of external dependency, we need to reduce them. So we need to try to be extremely careful on what we want to, reuse and how, and having a strong governance into that. And governance is not easy because it involves people. And therefore, we were thinking of something that it didn't involve people, but maintain the boundaries of a team. And the idea is, let's start with duplication, because definitely duplicating is far cheaper than the wrong abstraction. So like Sandy Metz said several times. And the idea is, okay, so if we start to do that, we need to be intentional what is available and shareable between teams. And the other thing is I need to create an artifact that makes my team independent. Because the reality is the distributed system is not designed only for technology, where yes, you have let's say the possibility to deploy something, there is a bug in an area and only that chunk is affected, the rest of the application works perfectly, but is mainly designed for your organization, for your people. Therefore, when you are designing this, you need to think about okay, so if I have a team that is responsible for the catalog, think about the catalog on Netflix, where you have like a lot of rails with all the different shows and different things. Then you select one, you have the details, and when you're happy, you click play and the video player starts. Think about that. That could be a nicely encapsulated chunk of the system for an authenticated user that enables the people to, consume, and I can assign to the team because it's not too complex. It can be, incorporated very well. And that basically for me was the first micro-frontends we built. But then suddenly, when we look into the video player, we saw a lot of complexity. We had 2 teams only dedicated on video players, where these teams were responsible for creating the heuristics and tweaking the heuristics on existing video players. For live content, it was completely different from on-demand. And every browser has its own codec. And therefore, we had to change the way how we were working. So now we had a micro-frontend that lives inside another one. So the catalog basically was one micro-frontend that was loaded. And then the other one was a video player. So in order to communicate, we need to think about how we are going to define this contract in an API contract first. So you start to see that a lot of similarities on microservices. What I'm describing basically is the application of the practices that we are used to do in a distributed system into front end that before it didn't happen. And today people are still struggling, because you need to have the experience on the other side in order to understand what fit on this side. So you need to understand deeply both in order to see, okay, this practice I can use it. This one, it will never work because there is no constraint and no need on front-end to do certain things. And therefore,
Right.
is super fascinating for me, that period of my life where I started to bring, let's say, patterns and mechanisms that were applying software engineering and see how I could shape them for front-end. If it makes sense.
Unpacking that in my brain will take a moment, but
yeah,
basically, to put a little summary on top of this. So the problem space is basically the difference between we do IT now and do IT 20 years ago is the scale and the speed, right? So if you look at this is no longer a technical problem. It's a socio-technical problem.
Correct.
And this is not a problem of writing good code. It's a problem of writing good code in cohesion of a responsibility and accountability for said code distributed among several teams. So we're basically definitely hitting Conway's law as a problem, right? So we need to design in a reverse Conway maneuver so that we change our organization towards the functionalities that we're building, split in domains, subdomains, and pieces of code being microservices assigned specifically. So the distribution of that system is a socio-technical distribution rather than purely technical. And of course, if we do it purely technical, we have a chunk of code that's easier to change, easier to isolate. Only that part is, and the closest dependents are impacted by a bug, fine. But in a software life cycle, that's a lot more to tackle in that
Integrated.
sense. There's plenty more. If we were doing this on a monolith, then we would have not only the whole system impacted by a bug, we would have also plenty of other teams impacted by the same bug. Where if we distribute that, we have less teams impacted, but that requires more organizational work and governance between those teams.
Exactly.
And this is also where coupling kicks in communication between modules, microservices, and communication between teams. We have different types of coupling between them now. And now the question is, what's going on in that coupling? Because that's interoperability on two different scales, one being the technical interoperability and the other one being the human-to-human interoperability.
Correct.
So because I just finished the course from Vlad Kononov this Monday. The course was on Friday, but I watched the recording because I couldn't join. I'll pop one interesting slide if I can find it. I think this is the one. I'll pop it on screen. There we go. So I had quite some fun looking at this table. Vlad describes 3 distinct axes of qualities of coupling, 2 of them being distance and knowledge. And the interesting part in this is that I have never really considered without looking at this table, is that low distance and low knowledge is actually something of a problem. It's problematic. I think this is something that you probably did tackle in the early days of micro-frontends as well. That you had low distance between the specific micro-frontends, but the teams didn't understand and know what those specific micro-frontends did, which created lots of extraneous cognitive load in trying to figure out what the hell is going on.
Correct.
And then, of course, if we look at it from my perspective of an integration architect, I'm usually in high distance, high knowledge being the problem, because that's the tight coupling between various domain systems, which is something you probably do not experience that much in micro-frontends per se. But if you communicate micro-frontends with the rest of the ecosystem, that's probably something that also may happen at times.
Yeah, the challenge I faced multiple times is shifting the way how people were thinking about these, let's say, interoperability between micro-frontends, because there is a different dimension when you think about that. You can have multiple micro-frontends in the same view, and that basically leads that at some point they need to communicate. 99% of the time, because since 2015, front-end was, let's say, working with the state management system. people were creating this thing called global state management that everyone can get access, write, reads, whatever. But it's more or less like having a single database for multiple microservices. What happens if I change the schema? That everything would have a ripple apart effect, and I need to retest everything, and I need to redeploy everything together, and it's going to be a colossal problem where people then point the finger towards, oh, microservices sucks. That is not true.
Yeah.
They are just facing a specific challenge.
And that's also similar if you apply orchestration. That's also a single point of tighter coupling in microservices in that sense, because the orchestrator needs to know a lot more about state. By the way, the next slide from this deck is this, which is basically showing what these lead to. We have complexity and complexity, which is the things we tackle at different areas. You tackle that in Frontend, I tackle that in system-to-system interoperability. The anecdote here that Vlad shared over his course is that when he asked this over a conference where people would like to be, would they want to be in the green or the red zone or the orange zone? Actually, quite a number of people pointed that they would want to, they would rather be in the orange zone. And we're going back to socio-technical problems.
Yes.
Job stability, job safety being the answer. Why would they remain in the orange zone? Which is interesting, because if they overcomplicate and make complexity, then they are secure for a job because nobody can figure out what's going on. And that's not the aim of neither proper integration architecture nor building micro-frontends in that sense, because we want these things to be, let's say, somewhat simpler, so that we actually can figure out what's going on and not have that additional cognitive load that makes us just horrendously tired over figuring out what's going on in our systems, right? So looking at microservices, okay, microservices being, micro-frontends being a specific, very specific specialized version of microservices that expose frontends. They expose frontends in various ways. We'll probably dig into that in a minute. Now, if you could outline what are the key differences of micro-frontends to the traditional approach to frontends, the monolithic approach.
Other than, of course, if you can share the screen that I'm sharing, I can show you and walk you through something concrete. Yeah, perfect.
Let's do this, of course.
Okay, this one is an example. Imagine that is an e-commerce. I'm not a designer, so don't expect great things from this e-commerce. I'm sorry about that, but I prefer to code. But the idea is very simple. So usually micro-frontends, in some shape or form, you have what is called an application shell. This is as simple as a container. So if you type www.mysite.com, first thing that you are going to have as response is an application shell. That generate is something that lives for the entire user session. So it will be there for the entire time and takes care about common things that you need to do with micro-frontends. So routing, composing micro-frontends. It takes care about retrieving the first, let's say, configuration that is read-only for micro-frontends. That's another thing that's important. So you cannot tamper it. There are techniques in JavaScript, like if you use object.freeze as a method, basically makes that object readable, but not writable. And that's one technique that you can use. I used like for almost 20 years when I was working on this stuff. And it's a good technique for saying, okay, I have this object, I manipulated it in a certain way, you bound to the contract, you cannot change the contract, because in JavaScript, everything is dynamic language, you can change whatever you want in the way that you want. And that's why you have often errors that are bubbling up here and there. And then in this part, usually what you want to have, like, it's the most stable part of the application that change context by context. I'll give you an example. This header, for instance, is as a navigation with an header, and that doesn't change in this example. There are companies instead that requires to have a team dedicated to any header because of the size of the complexity of that specific header when they work globally. Think about a large e-commerce that they use to buy stuff. And that is so complex because different services in different countries with different languages, all the permutation is making that very, very complicated. So that could be a micro-frontend. But in reality, majority of the time, 99% of the time, I would say it's not one of them. It's a simple component. Okay, so it's just an element that you want to have, reuse, have the same look and feel, because components compared to micro-frontends, one is micro-frontends, as we said before, they are aiming for independence between teams. The other one is aiming for reusability. And as Neil Ford says, reusability is a form of coupling. Therefore, we don't want to have components, but we want to have distinction between these two elements. So this one is basically it's a component baked into the application shell. At that point, when I'm basically going to this localhost 2000, I'm loading the first micro-frontend, this home page. As you can see here, I also, let's say, highlighted which is the version of the micro-frontend. This is React 17, because I want to show you one thing in a second. This one is composed by a bunch of things. Marketing hero, banner, bunch of products. When I select one product, click the product, at this stage for you was instantaneous. You didn't feel it, not because it's localhost, it would be instantaneous also on the web. What happens is basically loading a new micro-frontend and possibly sharing certain dependencies. That is completely transparent for you. There are frameworks that enables you to download a React version once and reuse across all the micro-frontends, or only the micro-frontends that require that version. In this case, we have React 18, so we downloaded a new version of micro-frontends, but they are living exactly in the same application, right? For you, the look and feel looks the same because you're using the same design system. You have exactly the same thing that you have in the past. But the cool thing is that here we have two levels of, let's say, navigation. So the first one is between first level URL as a call, so hard navigation between home to catalog. We are changing domain, so therefore we are loading a new micro-frontend. And inside the catalog, that team responsible for that will be responsible for having the full view of the product that are available and the, let's say, specific view on a specific product. It could be that they have also the review that is owned by a different, if you are a large team, you can have the reviews, the customer reviews that are coming from a different team. Therefore, it could be micro-frontends. But at the time, if you have a simple e-commerce, it's more than enough having a component. Those are just components that you can reuse in multiple parts of your system, but is reused inside the same team, the same, let's say, area of the application. And that, I believe, is one of the power of these things. So I can evolve this stuff in the way that I want. I can drill down and expand the capabilities of my catalog, adding more second, third, fourth layer of URL and drilling down with the complex routing mechanism, while the application shell takes care about the global navigation. That is basically the first level URL. Now, when I move, for instance, in my accounts now, the cool thing is that I have React 17 and React 18 that are already loaded because I loaded them before, but they can even live together. This is a classic example when you are migrating or when you are working with different teams. In a distributed system, the coordination is the part that you suffer the most between teams, because it's very difficult that you can say, okay, so now stop everything, don't deliver that feature because we need to update a version of React, Angular, whatever framework you want to have. Therefore, what you can do, though, is isolating, doing scope creep with multiple approaches, but this one is the one that I choose for this application, and say, okay, these both will work together because they are not sharing specific data, but just, let's say, an object that is, let's say, read-only, and is vanilla JavaScript. It doesn't matter the framework. Now, if I want to communicate between the two micro-frontends, like in this case, when I click make default, you have this toast element that is at the bottom. This is a component that is living inside the application shell because it's generic. It doesn't have to be lazy load. It has to be there because multiple elements can use this. The thing that happens is, what would you do in a microservice application if you want to, let's say, avoid point-to-point communication? You start to think about having a pub sub, because a pub sub enables you to publish an event and one or multiple subscribers will react to that. Same thing with micro-frontends. Instead of having let's say, a global state that maintains the state for everyone, where everyone can write and change potentially certain things, you just send an event that has a body. And if you think we are getting closer to a certain extent of messaging architecture. So you start to look into that part there, where in JavaScript it becomes extremely simple, because now I have these elements that is easy to test, because I know that is, let's say, subscribed to certain events, so I can generate these events and see how it behaves. As long when I push in production, the other micro-frontends are doing the same thing, then suddenly everything will start to work very nicely, because every team is independent in the testing phase, in the design phase. There is a little bit of coordination, obviously, because maybe there is a new design system that have some breaking changes, whatever it is, and they require these things. But if you start to think about the effort where you design carefully what are the touching points for the company, and when there are touching points, you create mechanisms, request for comments, architectural decision record, events that are typed and are capable to be shared across the system. You start to see that these areas of design the system, the social technical system, generate a very simple architecture, because now if I'm responsible for payments as a team, I will be responsible for the API of payments. I will be responsible for the integration, probably when I'm subscribe or the checkout phase for payment. I will be responsible for this view that basically enables me to change the things. So now my team responsible for payments, we know inside out that domain. We'll be domain expert with that. They can contribute with the product people to create a better user experience and a better UI with the designer, and moreover, they can take the right decision for the job, where very often we try to operate in economy of scale because we don't have enough bandwidth or people to cover the extent of a specific complex system. Now, if we start to look into this approach, now you see that your role as an architect or platform engineering, etc., is supporting all these teams in a way with, let's say, common practices that will enable them to work together closely, but without being coupled. Because sending an event is easy to test. As long as everyone respects that event, I don't have to coordinate with others. If I need to add a new micro-frontend because there is complexity arise or a new domain that we need to squeeze inside this view, but then become easy, because if I know what are the events that are bubbling around this view and the events that are available in the application shell, I just add new stuff. Even if I add the new events, I can add a new event, start to send it. No, the worst case scenario is no one is listening. There is no error happening inside the JavaScript. It won't block your application at all. And you can also have a lot of nice logic on, okay, I'm interested in that event. And then you can start to have, okay, can I have also this information with this other team? So you create a request for comment, you express what you need to have, and the other team can validate your request. And you see that now we start to look into holistically on the system. It's not anymore, I implement React and I use this stuff. Now we want to encapsulate, and the terms encapsulation includes data and methods. It's not just UI. So if you start to think about that, my payment methods is encapsulating all the knowledge about payment of that specific user in this case. There is no leaks. And if he needs to communicate on something that happens, can communicate passing the title and the description of what happened with this specific action, but the action itself can be reused by other places because you design in a way that is agnostic from the domain because it's living inside the application shell. A lot of these thoughts that I described, that I'm showing you here, are basically the process that enables you to create independent teams that reduce the external dependency, don't eliminate the external dependencies, but just reduce them, and they have more control and power on making change without interfering with other massive release that could happen. Then, in my experience, once or twice a year, sometimes 4 times, if you have like a very fast-paced place, you require to have something that's spanning across a new feature that's spanning across multiple domains. So in this situation like that, there is the requirement of coordinating multiple teams, trying to understand how these things will pan out in terms of contracts, events in this case, what kind of teams will be affected into that. I was in that scenario very often. But if you play very well your role as I don't know, staff engineer or group of virtual team that is working on the design, or architect, whatever is available inside your company, then you start to see some interesting pattern that if you design properly that chunk, the implementation will become a breeze because it will be part of the patterns that you have already created. And if you have a new pattern to integrate, you will have the possibility to test with a chunk of the system without affecting all the rest. So there are
Right.
the complexity is there because you need to think holistically on the system, but at the same time the reward is there as well, because I have, let's say, my previous company where I was working for this company called The Zone, a staff engineer that I met last year told me it's 8 years that we are working with this architecture, it never went through our way. We were able to, let's say, change the things accordingly for what the business wanted because of your principles and let's say design that enables us to be flexible where it was needed to be flexible and enforce boundaries where and generate friction where it was needed. And I think that was the testimony that design is still an extremely important part of software.
Okay, Luca, so to recap a little bit here. So the approach is as if with a microservice system, any microservice system, we're looking at having high cohesion within a microservice or a group of microservices that are bound to a specific domain or subdomain, however you want to name it, using domain-driven design or just plain language, so that within that cohesion you have a full understanding of the problem space, like payments or like catalog or like, if needed, the top bar of the website, and that's the high cohesion. And then looking at the distance between different domains, so either groups of microservices or a singular microservice and the teams governing them, then we have a higher distance between those two, so we don't need that shared knowledge as long as we describe the contracts well, whatever those contracts may be. Here being, like with microservices, either API calls or events, if we do pub/sub event-driven architecture within, exactly like with a microservice system, because it's very nice to combine microservice systems with event-driven architecture.
Correct.
That's a very common thing that happens architecturally. I'm curious because I've never been a front-end guy. I mean, I do write a little bit of HTML, but that's the extent of my front-end knowledge, because I mostly write it for all sorts of plugins that I do in my Google Workspace. So front-end is completely not my thing. I'm more of a middleware engineer, not even a back-end engineer in that sense. So I only utilize front-ends rather than build them. I'm curious. Could we dismantle this in a diagram to show lines and boxes, and where does that communication, what type of communication does happen here?
Yeah.
If you even take the example of Fred's Tales, which is this demo site that you have, perhaps we can use that, and you can then reiterate on this using some diagrams. Would that be a good idea right now?
Yeah, that's fine. Do you share the screen, or should I share the screen?
Yes, I'll pop in. So if any of you watching, we're currently live on Miro. I'll post the, I'll copy the board link and put this in chat on YouTube. There we go. And also we'll do this on LinkedIn if you want to follow us in the board. Otherwise, I'll just follow Luca. Let's see this.
So let's try to oops.
Diagramming in Miro, yes.
Yes, exactly. So let's try to do one thing. So this one was user details. Let me increase a bit, because otherwise everyone will hate me, and we are near Christmas, so at least we can say that we did good. And this one was payment.
Just for the sake of Santa not putting us on the list, right?
Yeah, exactly. I don't want to be the naughty boy, the naughty architect. Could be the next title that I could use, the naughty architect. And then we have here the application shell. Sorry.
Question: what do you get in Italy? What do you get from Santa if you're naughty?
Nothing.
In England, that would be a lump of coal.
Yeah, that could be that. But usually, it's for us the 6th of January. There is the Befana that I know is very specific for us, and it brings usually if you are a naughty boy, you have like the calls. So
okay,
but
in Poland, this is a stick. A stick to like whip
yes.
you, a flexible stick that we get if we're naughty. All right, so this is the shell.
This is our situation, right? Then we will discuss about the interoperability with the services, because also there are interesting discussion. So the first thing is I don't know how to draw that. Let's assume that we can do in this way. So you have like our object that could contain some configuration, okay? That is owned by the application shell. This is, let's say, the first element. Ideally, it's not always the case. Not everyone is implementing that way, but ideally, this should be read-only and is a property, like it tells you. Majority of the time, you have like, I don't know, feature flags. You have maybe some URLs that you need to provide dynamically. You pass, sometimes, for instance, I've seen some company passing the user data into either the HTML or exposed as an object inside the page. I remember when I did the reverse engineering 10 years ago on Netflix, they were basically adding the object of the user data inside the JSON object inside HTML in order to avoid to make another call. That was a smart way for optimization. But there are plenty of ways that you can do it. But usually you have a configuration of some sort. Right. The other thing is, at this stage, I can retrieve some stuff. You will have majority of the time. Let's see if there is the more shapes. There is the document shape. My shape. I don't. Yeah, there is AWS stuff, obviously. Okay, let's assume. Let's take this. Go where? No, this one. Can I take this? No, I need to upgrade, so I cannot. Let's take this. Okay, perfect. So. All right. Then you have like majority of the time a cookie that is your session that is leaving. This is available to everyone, right? So the cookie is something that is as long you configure it properly, because the security model of the cookie is that you have different, you can set up different subdomains there. You can say www and I don't know, payment.mysite.com will have access to this cookie. So the cookie will be accessible by every single domain. There are a bunch of other, sometimes you have a database that you can have on local storage, session storage, or even a web database that is available inside your browser that you can use. Those two things are accessible globally in JavaScript. So you don't have to do creating any fancy stuff unless you want to, but these are usually the things that are accessible. So basically, every micro-frontend will have access to the configuration. 99% of them will need that. Cookie, if you are in an authenticated situation, or or local storage, session storage, web storage, whatever it is that you want to have. Those are the things that everyone has available. Now, if I want to communicate with the application shell or with the payment, what you usually do is having this emitter. This one is, let's see if I can increase this. Boom. Okay, you have this emitter that is a singleton, so you have just once in you instance just once, and then you inject inside every micro-frontend. But the idea is that now my micro-frontend can, bidirectionally probably is better, can send an event to or receive an event from an emitter. And say, okay, I send an event that, I don't know, the user detail changed. I need to show a pop-up. And therefore, the application shell, in this case, will have a component that subscribes to the, let me see if I can do this. that subscribes to, how do I do a pop-up here? It could be this one. Okay. That subscribe to this specific event that is, let's create the event. Is called on let's say on user changed. Something better maybe, but let's assume that event.
That's a listener more.
Yes, sorry.
Yeah, user changed, I suppose the event would be then.
User changed, then what happens is you send this event, then the pop-up will have that on user changed. That basically will receive this event and will behave in certain ways, so showing the pop-up and then allowing certain things. The user change obviously can have an object with some details that you can use and that are useful for the pop-up, either for retrieving certain information and other things. So these are
so that's basically miniaturized event-driven approach.
Correct. It's literally a pub sub system. So if you think about that, JavaScript is already event-based. I click a button, I dispatch an event. The problem you have with JavaScript events, that is a problem I sorted out long time ago with technology called Flex, that was part of the Flash platform, and that shows how old I am.
I still remember Flash. Miss it dearly.
So the problem there is that even in JavaScript, you have a DOM structure that is basically a tree, right? So I can have different branches. And if I have, let's assume that we have 2 branches. So this one is living inside a branch, and this one is living in another branch. When if I use dispatch event in JavaScript, in order for me to listen to payment without referring to payment, because otherwise I create coupling. I know that today there is payment, tomorrow there isn't, so I need to change twice. So you don't want to do that. Majority of the time, what you do is doing this. So you do window.add event listener.
So registering the listeners to
exactly at the window object
somewhere.
But why that? Yeah. Because this one is the top object that composed the browser. So for sure will arrive there. The problem is the for sure part, because in JavaScript, I can also have inside my payment an object that what it does is, or a component that is a higher level component that has what is user change.
But it's further in the tree.
Is in between the payment and or the component that dispatch that event and the window. And basically we'll do, these are the little user change. You will have my function, and inside my function you can have a nice okay, event prevent event default, if I remember well the method, and this one basically stop the propagation, and therefore it will never arrive to Windows. Edge case, but when happens, good luck debugging. So instead, this is a way that is completely abstracted to any framework that works. It's like pure vanilla JavaScript. This usually an emitter is an observer, not an observable, an observer pattern. So I have an array of objects that are subscribing to a certain event. When I emit an event, it's just taking the array part, going through the entire array and saying on method, and then dispatching this specific event. The beauty of this approach is completely agnostic from the position. So if tomorrow I nest payment in a different way, or as part of another Micro-frontend, whatever it is, it doesn't really matter as long as it has the instance of emitter. So this approach simplifies drastically the way how you deal with not having to think about, oh, now I have, let's say, a potential issue that could happen. I don't know when it happens, because obviously at the beginning we all know we are extremely, let's say, pumped on applying all the best practices. But then when you have the first thing that you need to deploy for tomorrow, because otherwise there's a problem, then you start to implement and cut corners everywhere.
Of
And in
course.
this way, even if you cut corner, you don't crash. That's basically the
Right.
idea.
Yeah, because the tree structure makes it difficult. I don't really get to experience that because I don't get that levels of events in anything I write in JavaScript. But if I can make an analog in my head for in what I do, it's basically where I put the variable in my code matters in the tree
Exactly.
structure. So this is exactly the same aspect. If I put the definition of the variable very high in the tree, close to the very low in the tree, close to the root of it, then it's accessible to a lot of things in the code. But if I define it somewhere further in a loop or in an if statement or anywhere else, then I will have a problem because it will not be visible to the other parts, and then I need to like rethink all of this. And this is exactly the same issue, but at a different scale.
Correct. That's the challenge.
Yeah.
And this one is the communication that's happening inside the browser, basically, majority of the time.
Right.
Now, there is a communication towards the backend. And here we have a variety of possibilities. We can have GraphQL as an approach. So I expose like GraphQL. Why GraphQL for frontend makes a lot of sense, because if you have a majority of the let's say application nowadays are on mobile, are on web, sometimes in other devices, and the thing that I can query, let's say GraphQL with the information that I need only for that specific screen, reduce the chattiness. I can design the things in a better way. I download way less code that is not needed, especially the mobile teams are extremely happy when there is GraphQL on that. And there is a caveat, but we will discuss in a second. And in general, it's a great way, very, I would say, quite democratized nowadays. It's not that you need to get crazy on that. There is a very nice level of sophistication now in certain implementation where you can even have security on what you see based on the token or based on the role of the user. So there is, let's say, quite a lot nowadays. The beauty of this approach now, especially in the last few years, is that you have this idea of what I use, this one probably, schema federation.
Mm-hmm.
So where, if you think about that, I have multiple teams that are working on an application. We decide that we slice in a certain way our front end, our back end. Now suddenly you are introducing, let's say, a single point where every single request is passing through. How can I maintain the independence of the teams? And GraphQL come up with this idea of schema federation. This idea where I create my own schema for describing my own domain, and then GraphQL is creating a super graph that is bundling everything together. So I have it for front end is a unique layer that I get access to, but for the back end, I can evolve things in a way that are completely independent. So
Okay.
behind
so
here,
for those who are versed in domain-driven design, this for me this sounds like GraphQL created an open host service with published languages based on whatever is the domain you're trying to work, and that schema federation works as the repository of those published languages.
Correct. So the cool thing of the schema is that you think about you create a schema and I need to consume that. You create one, and then another person will create another one. And somehow I need to find myself that I can combine different domains, because the domain on front end might not be the domain on back end. In the previous example, for instance, you probably have a user domain and you have a payment domain that will be some foreign tables, some communication between these things, depends from the complexity that you have. But the reality is these two things will be distinctive. But in the front end, we want to show both. And therefore, as you can see now, you are in a situation where you create something ad hoc. For instance, this GraphQL won't require that because you have the availability of multiple domains available for you, and that could be okay for certain companies. In certain scenario, though, there are, let's say, if you start with REST APIs, you want to keep REST APIs, because the problem is not that GraphQL will create technical challenges, but will introduce philosophical issues inside your system, because the way how GraphQL let's say, democratize the information is maybe something that you want to do on a certain part of the system. At the moment that you introduce something like that, in 6 months' time, I can guarantee you that happens more than once. Someone will say, but that team is using GraphQL. Why cannot we use the same? Because we have a similar problem. And that opens up a door of different philosophies, different way to update APIs, different ways to consume APIs, different way to scale infrastructure, and that can go ahead forever. So for me, it's very, very important that when we, at the beginning of the discussion, we were saying, guys, let's try to think and design things in a certain way. You look into this problem and understand, okay, GraphQL, it's something that we want to embrace. We know the trade-off, what they are, so we democratize the information. Is it fine for what you need to do? Because then if you have high volumetric and it requires, let's say, I don't know, you have million requests every second, then you need to scale horizontally. It's totally doable, obviously. But one thing is, let's say, handling, let's say, one service that has to scale, I don't know, 200,000 requests per second. One thing is scaling one that is 1 million, and if it's down, basically the whole system is down, right? So you need to be careful on how you design these things. You can potentially think about a backend for front-end approach that is domain, let's say, divided by domain. That could be another approach that you can think about. Where you just basically have the possibility to not having a schema federation, you just have a REST API that aggregates a bunch of APIs from different domains potentially, or the same, up to you. But then it means that I will have a proliferation of those, so one per domain. I don't know, BFF.
If you are actually partitioning per domain, because I would argue that depending on the maturity of the organization, the maturity of the teams, you may just have a single BFF that will handle all sorts of domains, because you haven't even thought about domain partitioning at this point just yet. You have more of a functional partitioning and technical partitioning rather than actual domain partitioning.
For me, because in my experience, there are, I can tell you, in my previous job, for instance, we use one BFF for one domain that was my account, for not having to deal with exactly this problem here. Because when you have multiple micro-frontends, you need to create governance into that. Who is responsible for end-to-end testing? Who is responsible for integration testing? Who is responsible for making sure that we need to define these API, these events, and therefore everything will work? Who is creating so there are a lot of who is created. So the ownership part becomes complicated. So how I solve that is say, okay, I can have two teams responsible for that, or I can have a BFF for my account. Let's go my account here. That includes payments and user details and whatever else we had in the past. So now that this team is responsible for one micro-frontend, okay,
that services to that services different things.
That is super simple. The domain aggregation is done at the back end, and still the same team is responsible for these things, and they remove all the complexity on governance.
Right.
It was the only domain that needed this specific treatment, introducing GraphQL like it was asked from developers, or let's say handling micro-frontends differently, but then having all the complexity on updating and all the other stuff. I resolved in a very simple way. I created back and front in my account. The API weren't changing very often because I check the code volatility of this API, so the control remained fairly stable. Also because we have, let's say, payment APIs are delicate in general, and user are the same. When you define user, usually you augment the API, you don't do too many breaking changes in a year. So code volatility-wise, we were fine. And that enabled me to have, let's say, a single point where I aggregate all the information. The team was responsible to switch when needed the right version of the of the API to consume. And the micro-frontend, it will have always the same let's say, a contract. So it will be a team, very easy to maintain that micro-frontend. The only thing that need to take more into account is the backend front end. So as you can see now, here the decision, it wasn't, oh, let's play with GraphQL. It's trying to figure out what means for me in terms of trade-offs if I have multiple micro-frontends in the same view, and analyze what is the benefit of instead introducing a middleware and disaggregating the data, because in reality they're not changing very often, and the traffic on that specific area, my account, if you think how often you go to my account in Netflix, is probably once a year when your credit card expire, or when you want to change your email, stuff like that. So it
Right.
wasn't, let's say, the complexity wasn't worth it for the domain that I was designing at the time. And that's another key takeaway, in my opinion, that very often, again, we are not playing with best practices or amazing tools or bleeding edge tools, but we reason around what is the trade-off that really makes shine that specific context, because context is king. They can provide the best effort without, let's say, create too much complexity.
So basically here we not only have a trade-off analysis over, let's say, the functional aspect of this, because we have the scope of usage, the volatility, which is one of the degrees of coupling, as described by Vlad Kononov. But also we're looking at the socio-technical aspect of what is the trade-off then from a socio-technical perspective over responsibility, accountability of different tasks around the whole life cycle of these components. So development, making changes, maintaining this, testing this end-to-end, and all of other aspects of communication between teams. Yeah.
As I was saying at the beginning, the whole point that I started with the principles behind a Micro-frontend, and one of them is being independent. That was my North Star to follow. Therefore, if I design things without thinking what is the impact of my developers in terms holistically, in terms not only on cognitive load, but also what is the effort, what is the governance I need to create, what is the platform, what the platform teams needs to do. There are extra new things that we need to think about ownership and stuff like that. I'm making a disservice to the company, because again, it's not the architecture that is failing. It's you that you are, let's say, simplifying too much the complexity of building software in a distributed system, because a distributed system has a complexity that is in three dimensions always for me: architecture, engineering, culture, and team topology, so organization structure. If you're not seeing these three dimensions holistically when you do trade-off analysis, then you are basically taking a guess that you might have the right decision or not, and then blaming architecture because there is friction inside the system, without understanding that that friction is the way that architecture or a social technical system has to tell you, by the way, you didn't think about the other dimensions.
I like to refer these kind of points to Tesla's law. You probably know Tesla's law because this is a very common law used in user experience. I personally use this for system-to-system interoperability because it's still very much applicable. And Tesla stated that there is an inherent amount of complexity in the problem domain that is irreducible. And we can add accidental or additional complexity to it by over-engineering, by over-complicated, or over-simplifying a problem.
Correct.
And that complexity, the question is who's going to handle that complexity. And basically, by what you're saying is adds degrees to where that complexity can go. It can or derive from, because it can derive from architecture itself. It can derive from the engineering culture and the team topologies to the organization itself, or go to those places if it's poorly addressed in any of those categories that you mentioned.
Completely, because if you see this example that I made on purpose, this approach is technically is sounded, and similarly, this approach technically works because I'm maintaining the separation of concern between the elements. Now, the problem is in a vacuum, both will work and will be well designed. But if you start to add a new layer that is the context, so the business requirements and the architecture characteristics and the engineering culture and the organizational structure, now you start to say, but probably this makes more sense. Because looking at the vacuum of the technical solution nowadays, especially in distributed systems, is, let's say, being a bit blind on the reality of the case. Because if you are not capable to have a full understanding of the system, it's very difficult, and the context is very difficult to say this is the direction of travel. I as an AWS specialist, what I'm doing is jumping in a customer that I maybe never speak with, and that half of my discussions is around organizational structure and what you're trying to achieve. What are the goals that you have? What is your volumetrics? What is your availability goals? Stuff like that they know will impact whatever I'm going to say after that. And usually after 40 minutes that I'm talking about all of this, in 20 minutes I can solve the problem. Because now I have all the context of the word, and I can tell you, listen, you are doing this, but the problem you have is that if you're telling me that your teams are doing this, that probably what you are implementing doesn't work. Either you change the way how you structure a team, or you change the way how you implement these things, because otherwise friction will arise anyway. So it's not a problem of technology, it's a problem of that you didn't think holistically on a specific part. And that's why I, let's say, in the last 10 years, I mastered a lot this kind of multidimensional vision as architect, because enables me to look at things differently from a developer that unfortunately they are forced to look into their chunk of the system, and therefore they master that part. They are extremely proud of their craft, but they don't, let's say, take a step back and look, okay, what are we trying to achieve here? And that's where I believe more senior people like staff engineers or architects or engineer manager, whatever, should provide that information to feed inside the teams for taking better decisions.
There is a quote attributed to Einstein that Einstein, when asked, at least supposedly, if he had 1 hour to save the world, what would he do in that 1 hour? And the quote is that he would spend 55 minutes in understanding the problem and 5 minutes actually saving the world and fixing whatever is wrong. And I found this, I believe this exact attribution to the quote was somewhere in the book I was recently reading, a very nice one, Domain-Driven Refactoring. Mm-hmm. And basically, in the book they touched, because refactoring is also a psychological problem. They touched upon what you already hinted at for the perspective of developers. Developers or engineers in general, they hate to be in the problem space. They like to be in the solution space. Oh, we see a problem, we jump to solutioning.
Exactly.
And that's from a perspective of business or from a perspective of architecture, that's pretty much the worst thing you can do. Because then you have a solution that doesn't really fit the problem, and it doesn't really solve the problem because it didn't take enough time to understand what the problem is, and potentially the solution should have been a lot simpler.
Yeah.
So already by solutioning instead of architecting, we jump into making assumptions, and that's always going to be painful to a certain extent. And this is why this kind of trade-off analysis, and also looking at the other axes of the problem, like engineering culture or the organization or team topologies, the dynamics between teams, is crucial to build a proper architecture.
Absolutely. And that's why, honestly, what I'm trying to do is democratizing this approach and trying to provide, let's say, a distilled version of all the things that I discussed so far in my book, in order that they don't have to do what I have done, and they can, let's say, apply these things properly. In my book, I spent like plenty of time to describe migration, the status of the specific context that I was doing, and stuff like that. Mainly because I want to, let's say, start to make them sensible on these topics, because it doesn't come for free. Very often I have seen, let's say, teams blaming Micro-frontends, and when they maybe try and they failed, and then they start to speak with me, and I start to dig deeper into the topic, and I explain them, oh yeah, but your friction was generated by that from what you're telling me. I say, oh yeah, you're right. And then they give a second chance. The second chance usually is successful. Because it's the mindset. It's not because I'm a genius or I'm better than others. I'm definitely not. I'm a definitely average person. But the thing is, what differentiates me is that I started to look holistically on these things, and everyone can do that if I was able to do this. But the thing is, you need to understand that the problem space is bigger than what you expect.
Mm-hmm. That is definitely true. Usually, in general, the majority of the problems we have in IT are not technical problems.
Yeah,
We need to
completely.
solve them on the level of a conversation with our stakeholders, conversation with our business, to understand what is the actual business need, not the business want, to be precise, because the business will say what they want, which is not precisely what they need. And for us as architects, this is the part where we can step in to actually translate what they want from us into what they actually need to be built and developed, and then we need to figure it out how it is supposed to be done. And this is the difficult part, because this
Correct.
is where we as architects really don't need that technical knowledge. We really need a lot softer skills, right? Uh, Conversation, capturing nuances, discovering things, being pretty much business analysts. And that's, for a lot of people, it's very difficult, especially if they're just beginning their journey into architecture.
Oh yeah, yeah. It's a role that you grow in more than you're ready and you just, let's say, start to do that. You need to push outside your comfort zone very often, and definitely technical background helps because you have, let's say, already one part of the problem in your head. You don't have to be, let's say, the best developer in the world, but definitely having a bit of background, in my opinion, helps because you have, let's say, a portion of the system there. Then I was lucky enough to be in a situation where we needed to move fast, and I have the possibility to look into the other two dimensions, and that's where probably let's say nowadays I'm more confident to say this is going to happen or this is the right solution because I was able to see them firsthand.
Mm. Yeah, I think that experience you had over this fast, really quickly growing company, I think that really shapes.
Yeah,
Uh, if you, like me, if you work in consulting and you're exposed through projects just to a small snippet of the problem space, it's a lot harder to grow into the role of an architect that way, because you don't have to tackle all those
correct.
aspects. You just tackle what you're served in terms of tasks in Jira or whatever other system that you agree on the scope of work. And that's very problematic for people to grow out of that mindset and to look at the broader picture, to have that holistic view of what's going on. And this is something that is really needed. And I learned that kind of the hard way, but I also had, through reading the works of Mark Ratius and Neil Ford, that really helped me further develop that view into architectural thinking, instead of being narrow-minded into that technical thinking, because it created more friction for me than it needed, really.
Yeah, totally. I think when I had the possibility to jump from product to consulting, I always said no for a certain period of time because the challenge you have usually is if you work in product, you take some shots, some decisions, but before you see the impact of your decision, it will take probably between 6 to 18 months from when it's in production. Before that, it can be as good it could be, but the reality, you need to play the long game in architecture, because the more you see things that, okay, I decided this was the context, this was the situation, these are the outcomes, and these are all baggage that you usually have in consulting. Vast majority of the time you arrive to deployment of a solution, you see a chunk of the system. If you are lucky, you have a contract that is long enough to see these things, but is not given for granted. While if you are internally in the product, you evolve the product over and over again, and that you see all your decision, right or wrong, or right for the context that has to be changed, but you have the context of why you take that decision at the time. Luckily, maybe you also document it in architecture decision record, but then you have the possibility to iterate into that based on the involvement of the social technical system. And that for me is where really you learn how to do architecture, let's say, properly. Because very often, if you just, let's say, move from one project to another one, you will have a lot of breadth of use cases, but you are not going to see if your decision will have right or wrong impact. Because very often I'm with consultants that are telling me, "Oh, I was doing that," and then it turns out that some of them was one of my customers in AWS. And when I spoke with them, we were saying, "Oh yeah, this consultant did that," but basically after they left, they left a mess because they weren't capable to scale at the level that we needed. And then basically they call other people, to fix that, and they validate with us. So this situation happens over and over again. So I think it depends what in which let's say part of your career you are at.
I was lucky to move back and forth between consulting and being in-house, so I have the two perspectives, and
Exactly.
it really depends on what you need right now in your career. Sometimes you need the breadth of knowledge and to experience different technologies, experience different projects, different types of projects, because you got bored by your in-house project, which is constantly in the same scope of business problems. So that's no longer interesting. Other times, it's really, really nice to see over time how your work actually impacts the organization. And I remember this lovely part where I was still a junior developer working in consulting, and then I moved to my client to have an internal role later as a architect. And I opened, that was back when Subversion was still a thing, not Git. And I opened Subversion, like, who the hell screwed this up so royally? And I saw 4 years earlier my name under those comments screwing it up so royally, and I was like, oh, okay, this is a growth moment, right? This is where the perspective comes in, kicks in, and now I have a proper understanding of what's going on. And this is important to put that context in.
Completely. I think it's just a learning thing. So in order to become an architect, you need to design a lot of stuff, see the impact of your design, and it's easier to a certain extent if you spend a few years in the same place, because you will have a better perspective because you understand the context. Then moving between contexts, you can take away between contexts in terms of industries potentially. You can take away a lot of your learnings and apply in different industries. But I did something similar like you. When I was living in Italy, I had my own agency. So I've seen a lot of, let's say, breadth and at the beginning of my career. And when I moved to UK, instead, I started to work more on product because I needed to go deeper. I needed to see the impact of my things, either as a developer or architect, whatever it was. And that worked out till, let's say, a few years back, that I decided to go back in a certain way in consulting in AWS. Because there I wanted to see where my depth and breadth was reaching the tipping points, and see if what I'm missing, what I didn't see, or I didn't discover yet. And the possibility to work with large customers, obviously, was for me extremely important for my career, and validate basically my learnings and learn new things. That obviously was one of the key aspects for me to join a company like this.
Yeah, it's these paths are crucial. It's crucial to have a little bit of a reflection over time, where you want to go next and what you want to do and
Correct.
why. Not just do random moves in your career, because these moves will definitely shape your thinking and the way you do things. And it's always a difficult choice in that
Absolutely.
sense, because
Absolutely.
there are so many factors that go into that decision, and your opportunities for growth from that perspective. So yeah, and this later translates to these kind of lovely designs like micro-frontends, which is
Yes.
which is amazing. Okay, so if we had our micro-frontends, we had the shell app, we had different micro-frontends embedded into that shell app. We discussed GraphQL as a means of reading data. Do you use GraphQL at all for writing data? I don't think it's a thing.
Yeah, potentially you can do also that. It's bi-directional completely, so it's not a big deal.
Okay.
You can even have subscription that basically enables you to have a WebSocket under the hood, and when one thing changed on the back end, it will be
Okay.
let's say, displayed inside the UI. It's extremely powerful. To be honest,
Mm-hmm.
I've seen a lot of the capabilities offered by GraphQL used with micro-frontends or with monolithic application, but majority of the time I've seen successful implementation on multi-device approaches due to the nature that I can query whatever I want. And now with schema federation was a big plus. Now micro-frontends,
Right.
let's say we borrow the idea of schema federation where you compose things in a single schema, creating a super schema, and that's where you lazy load stuff. And since I would say 7-8 years ago, we started to see a proliferation of frameworks that came out on micro-frontends, but now also the new frameworks, the server-side rendering one, the one that you usually use for e-commerce, the most famous one like Next.js, Astro.js, etc. They have as micro-frontends as first-class citizen inside their system, because you can use what they call React Server Components or Astro Server Island that are basically implementation micro-frontends. They are similar principles. They don't call micro-frontends, but you can build micro-frontends with those. I have several examples in my GitHub repository with Next or with Astro, just to show how you should think about it. Because the reality is, when you understand the architecture, you are in a position where that doesn't matter anymore if it's edge rendering, server-side rendering, client-side rendering, a desktop application, a mobile application, whatever, because the logic is always the same. It's architecture at the end. It's not a framework. You're not bounded to a framework. You are bounded to, let's say, an approach. For me, it's in the book I describe what I call the decision framework. That basically are 4 decisions you need to make in every single architecture. Every time you design with micro-frontends, I encounter this decision every single time. So how to slice a micro-frontend? You want 1 micro-frontend loaded per time, multiple of them. Obviously, are not mutually exclusive, so you can choose certain domains. You will have multiple micro-frontends, like the one that we show in the diagram. Some others, you might have a single micro-frontend, like the catalog that I was showing in the demo, and it's fine. But then you need to think about how you route and how you compose. So you do on the client, you do on the server, you do on the edge, because, for instance, I applied Strangler pattern on the edge for migrating from a monolith towards the micro-frontends in a very nice way, because that enables me to, I have to pass through the CDN no matter what I do. Therefore, I can start to have some smart logic. I can even do, I started to have canary releases at the edge, where I say, okay, every time that you call this micro-frontend and I have a new version, I want that 5% of the traffic goes with the new version, only if they are in, I don't know, Germany, and they are in Google Chrome. So in this situation like this, I can shape the deployment. That basically the idea of introducing this was creating a safe net for developers to reach production more often. Because as the book Accelerate taught us several years back, we were looking into DORA metrics. So we want to go as fast as possible in production, because it's one of the characteristics that enables a successful company to succeed. If you create a safe net for developers, they are capable to, we for instance, this approach moved the needle from 2-3 deployments per month to 25 per day per team. So we end up with microservices and micro-frontends at the end of the month, when we started to have, let's say, a certain maturity, that we had thousands of deployments per month across different layers. But that tells you how fast you can go, how safe you can be, and stuff like that. And did we screw up? Of course, because natural, like we have human beings in the mix. So sometimes you forget about a specific configuration, you forget to put behind the feature flags, you forget about these things. But that nevertheless doesn't mean that screw up the proposal. It's just, okay, we found a blind spot. We need to understand how we can mitigate this blind spot that doesn't happen again. This is the mindset that, in my opinion, people should have, more than first thing is, okay, let's create a gate that basically is preventing people to deploy, and we hide behind this change advisory board that should know everything about everything that is happening inside the company. Usually, even if you have like the smartest people in the company, the cognitive load is finite, so they will never be able to tell you this specific this specific service will not clash with the change on this other specific service. So you are basically creating friction that is a safe net for the management, not for developers. So let's invest more in automation, and we create something that makes more sense for developers, because those are the one that needs to speed up and be safe when they deploy.
Right. Did you mean Accelerate? Did you mean the book by Nicole Forsgren, Jez Humble, and Gene Keem? So
yes,
if anybody would like to dig in, here's a QR
study
code.
Of 200 companies worldwide, where basically in the first part of the book, they describe what are the traits of successful companies. And the second part, they describe how they tested, or better, how they conducted the research for retrieving this information. What they discover is that there are some traits that makes companies successful. One is how fast you can deploy, how fast you roll back if there is an issue, how fast takes from ideation to production, and that basically is the base of the foundation of DORA metrics. And that was one thing that nowadays in the industry is quite well known. And now there is a new book from Nicole called Frictionless that I think came out last month, if I remember well. And he's basically moving to the next step. I didn't read it yet, but it's definitely my reading list.
Okay, I don't see it at the Riley. Would have to dig deeper to find it, but yeah.
Let me see if I can find it. Frictionless.
Okay, now if I just still took a look at the diagram we drafted on Miro, and I'm looking like, okay, so we have interoperability between the micro-frontends being through the emitter, so we have event-driven like aspects that are avoiding the JavaScript problem of events and listeners. Then we have interoperability between the micro-frontends and the backend, as in GraphQL or backend for frontend. And then basically, if we have that layer of a backend for frontend, whatever version that may be, then basically that is our abstraction layer that we then go into communicating with the rest of the ecosystem.
Correct.
So this is where my job begins, how to get that data moving between that particular backend of that frontend into the rest of the ecosystem. And this is pretty already standardized in comparison to what we have in micro-frontends, where that for me is something that is very much abstract, because I don't do it simply, not because it's that abstract. It's just something that as an architect I do not really touch upon, and that's the interesting part here. So that's any things happen specifically if we talk about external communication, as in available from the internet, because if we look at the front end is available from the internet usually, right? If we have a product site or whatever, but then what is that?
If you can share again the Miro board, I would like to show you one example.
There we go. Back to the Miro board.
Amazing. So let me zoom in here. Okay. So imagine that this one is your, I don't know, server-side rendering page. Oh, sorry. Server-side rendering catalog page. And you have classic example, catalog. And you have a classic example, an external advertising server. Let's do it this way. So you have ADS server.
In
that
the meanwhile, while you're drafting, I put the QR code for frictionless on the screen.
yes.
So if somebody's interested in looking into that, that's also there.
So in this case, for instance, I want to do server-side rendering of my catalog, but the ADS server is an endpoint that I basically provide personalized advertising based on the user, and I show basically a specific element inside the page. So that cannot be cached, has to be retrieved dynamically from advertising servers, etc. So what you do usually is that this has to communicate with whatever system you have, from mobile to whatever. So you go with the common denominator, that is HTML, basically. And what you have here is when you are fetching this information from here to here, you are going to have back, let me reverse that. You're going to have back what is called an HTML fragments. What is the text? Text here. That is nothing more than an HTML element that is self-contained, that contains all the graphics, text, whatever it is, based on a bunch of parameters. So now at this stage is, to a certain extent, potentially malicious code. If I intercept that, could happen wherever it happens. So the tendency of what you do is sanitizing this code and HTML. And HTML usually is not malicious because they don't provide, let's say, a lot of JavaScript. There is probably a non-click things. If someone is clicking, is attributing that thing to the advertising or whatever it is, but it shouldn't be, let's say, too much logic. So this one is usually sanitized, injected inside the page that is rendered and shipped to the user. Now, the other approach that now is not there yet, but it will come very soon, I would say, is when you have an AI workload. Now, the AI workload, what is going to generate is JavaScript, right? So I have a chatbot, and imagine that at some point, let's say I want to do a trip to Florence. And instead of providing you a text-based approach, it's going to generate UI where you have a video of the, let's say, what people were seeing in one place, and maybe they have, I don't know, some other ideas of what could, I don't know, a common itinerary or the most hotel from the people are coming from your country, wherever it is, right? So these are classic example of micro-frontends, if you think about this, because instead of providing you contextual text that is explaining one thing, you can have instead graphic things that are generating in an encapsulated way with a set of elements, and then pumped with data that God knows how they are generated, right? So in a situation like that, now you have a bunch of full micro-frontend potentially. Okay, we are in the realm of if, when, and is going to happen, but you are going to have JavaScript here. There are already some examples that I've seen on mobile, for instance. It's very interesting, this approach, but imagine that you have like here JavaScript, a micro-frontend JavaScript that is fully JavaScript. Now here can be wherever, right? And it can be also that the implementation screwed up because it's using a specific version of a library that doesn't work. It has a bug, has a security issue, wherever. So the idea here is, okay, how do we sanitize in a situation like that? And probably we're going to need something new, or let's put this one here, that sanitize this. That is a code sandbox that takes the code, parse it, run wherever scan you need to run in this code sandbox, and then finally reaches the part that you need for communicating with your system.
Ooh.
And that is becoming very interesting, right? Because now suddenly you can generate code on the fly. You can apply your UI and your design system because LLMs will enable us to do that. And now we have, although for security reason, you cannot trust whatever is coming because we know when we play with code assistant that the precision of the code is generated is probabilistic. We are dealing with a probabilistic system. It's not deterministic. Therefore, that you like it or not is going to screw up. So the code sandbox will become a sort of, if you want, safe net for us to have this feedback loop that is communicating between the LLM and the agents to understand, does it, let's say, work in the way that it is. But if you start to think about this, now you became to add a lot of security stuff here, a lot of logic and deterministic thing, security, style, etc., whatever it is. Now think how powerful it could be in transforming what today is a non-deterministic system that generate, rightly so, non-deterministic or probabilistic, let's say, responses, because if you ask the same thing, it could provide the same answer or not.
Sure.
But now we start to add a bunch of layers of determinism in this probabilistic system. And what if we are not going to have like the perfect deterministic system? There is no way that a probabilistic system can turn into a deterministic system unless you change the underneath architecture or, let's say, implementation, mathematical implementation behind that. But in this case, we start to create, let's say, a safe net that will reduce drastically the way how we could screw up. And if you are if you're in a situation like this where the things are small enough, we are not asking to build an application, we're asking to design a thing with a certain constraint, then I think will become quite likely that we are going to have something that is kind of interesting and could scale very nicely, because with all the microservices approach that we have learned overall, we start to have like, I don't know, imagine a dashboard, one micro-frontend that is generated from LLM that have a bunch of safe net that will be served by a single endpoint that is integrated through micro-frontends inside the same UI. Now the things start to become very, very cool, because with this approach, you have a mix potentially of deterministic, non-deterministic systems, or semi-deterministic system. I don't know if there is a term in English to define that, that although you still control to a certain extent. And it's just, let's say, being good on defining these, let's say, rules or deterministic nature for reducing or eliminating the possibility to have some outcomes that are not, let's say, I don't want to say correct because it's the wrong word, but as expected.
Mm. And this is probably where a number of externalized APIs will come to play to be able to facilitate that.
And the
and
frameworks already have them, because the React Server component is nothing more than an endpoint where you basically render a chunk of the UI and is embedded inside a static part. So it started to become extremely interesting, this new world. This is an area of research that I'm currently looking into to see how far we can push these things. There are some missing parts, but we are getting there.
Okay, that's probably going to be a very interesting future, and also touching upon interoperability, to how to properly govern that and make those AI workloads hallucinate less and work to our advantage, because working with non-deterministic systems is already a difficult aspect. That's only always.
It is.
And I think this is...
We need to take for what they are and not trying to make them doing something that they are not designed for.
Or design specifically, so train LLM models to be in a specific use case of micro-frontends and serving content.
Yeah.
So this is a different topic, where we have training and then fine-tuning, where training is towards working as a micro-frontend, and fine-tuning would be then the training the model in the aspect of that business or that site, or
correct,
whatever the purpose is. Ooh, that will be definitely an interesting avenue of research in the next years, to how to properly make it a tangible use case.
Completely. I think, it's just that this let's say, idea itself, it could literally lead to a very interesting approach overall, where it doesn't have to be let's say, developed fully by developers, but you need to create the governance around certain things that are developed as raw elements and then augmented through AI on the fly, and then compose with all the distributed system nature that we have learned overall. Because now we are designing a UI and not generating certain type of code. So there are a lot of nuances there. And with all the checks that I was mentioning to making the output not harmful for the system, it started to become a very interesting thing. So we need to understand how much we can push the boundaries.
And let's leave it at pushing the boundaries.
Yes.
Hopefully somebody will pick it up and try to push that boundary alongside you and others who are already doing this. And that said, Luca, thank you so much for your time and for your explanation into interoperability of micro-frontends. That's been enlightening. Now I know how they work, at least. For me, it's as an integration architect, it's easier to comprehend the nuances, and I see analogs to my work just on a completely different level. Before we go offline, this is the last stream we are doing this year, but next year, I already have a pipeline of loosely coupled till the end of February, so there's some interesting talks coming up. First one on the docket is with Chris Simon. We're going to be talking about the living language. So we're going to be talking about how to maintain and how to work with a living language or a ubiquitous language from domain-driven design, how to make it maintainable and how to keep using it without sprawl and deviations that would be harmful to our organizations. I think this is going to be quite a challenging and interesting conversation to be had. And that's on the 14th of January. So we're taking a little bit of a break over the holidays and New Year to reset and do some other things than live streaming here. And that said, again, Luca, thank you for your time. Thank you for joining us in this lovely last session of the year. Happy holidays.
Happy holidays to everyone that is listening to us, and they are, let's say, listening also to recording. So happy holidays to you and your family. I hope that you have a good one and relaxing one. Thank you again for having me.
It was wonderful to have you, and everybody, happy holidays and happy New Year. See you next year.